chapter, we are going to create the anemones simulation using Vellum struts. That's the result of this chapter. Let's create that. Let's create a subnet first to organize our project. Let's rename this to Anemone. Anemone. Change the color. Let's go inside. Let's organize this. Create a geometry node. The first geometry node should be the anemone tentacles. Anemone. The second geometry node should be the anemone body. And the third node should be a loop net to create our shaders. Let's color this a meaningful color. First, we are going to create the tentacles, create a line node with the full values. Let's create a sort. To reverse the point order, this should be important because we are going to make this line thick, more thick. We should give a thickness for this line. Let's reverse the point order, okay? Resample this line like 0.0125 at maximum length. It should give us around 80 points, okay? Let's create a group and isolate the first point here. Rename this group to root. Put here the variable $OS. To the group name, it retains the name of the node itself. Change the group type to point. And here in the base group, only the first point will be necessary. Now we create a sweep node. Change the surface shape to round tube. Disable this display point numbers here. We don't need this right now. The ends should be closed. Here in end cap type, we can change this type to grid to create like a semisphere. And apply scale along the curve just to adjust the thickness. Let's see this tube from the front and adjust some parameters here. This should be around the 0.5. Let's create another point here. Change here to B-spline, the configuration of the ramp. This should be around 0.32 and the value around 0.37. Create another point here. Position should be around 0.73 and the value around 0.415. We will need to adjust the tip here. Let's decrease the size a little bit and create around tip from the anemone. Here you can see the reference of the anemone. Let's just think about the tentacles. The tip of the tentacles is like a small sphere here. We are creating a small sphere at the tip of each tentacle. Let's adjust here the ramp to make this more like a sphere. Spherical tip. Like this. I think like this is enough. Should be like a small tip in the small sphere in the tip. Now you just need to create a UVs for the shader using a node called the UV texture. This texture here should be in cylindrical projection type. Let's see the UVs. You press space 5 to see the UVs and change the scaling X like 0.25. We don't need the whole area of the UVs, just this part here. I create a texture in Photoshop to apply to each tentacles of the anemone. I try to replicate like these fragments in the design of this reference. Let's see this in Houdini. You can use a quick UV quick shade to see the texture applied to the tentacle. Here, just enable fixed boundary seams to fix the boundaries of the tentacles here. Let's see the color, the texture. It's cool. You can disable this node just for visualization. We need now to create a gradient node. Labs color gradient. In the Y, we just keep the full values of the gradient. And let's translate this, transform these tentacles down in the Z-axis. Rotate here the 90 degrees. And squash a little bit in the Y, like 0.7. Okay, it's working. We need to create a copy to points, and right now you need to create the points to make the copy of each tentacle for each point. For this, we create a torus. Adjust the torus size here for these values. Here should be around 40, 50 columns. And here in the detail, disable the U and V wrap to apply some modifications in the torus. Here, in V angle X, change it to 250, just to clip where the start of the torus radius. And here change it to around 410. Maybe 400. You can see a seam here. Let's fuse that. Just to make sure the points is fused in this area here. Without fuse, you can see overlapping points. Just enable the fuse. Adjust the radius of the torus here around 50. Okay. Create a normal after the fuse, just to get the normals working for the torus. And use a scatter node to scatter some points on the surface, around 200 points. disable the normals here to see the result, and increase the relaxed iterations to make the points keep the distance from each other. We don't need the normals after the points, we can delete that. Attribute delete, and delete the point normal. Actually, sorry, we need to keep these attributes. We delete everything and keep the normals. Create an attribute randomize to randomize the p-scale value. Change here attribute name to p-scale. Change the dimensions to 1. And minimum value of p-scale 0.7 and maximum 1. You can connect the copy points to attribute randomize. Now you can see this configuration here. All the nodes is applied correctly with the different p-scale each other. Let's see just the color without the gradient. We can delete everything, every attribute from the geometry, just to see the configuration here. It's working pretty nice. Now you can create a symbol node because we need a name per attribute for each tentacle. Here in the primitive, we need a different piece name attributes for the primitive. We can change here output prefix to tentacle underline. Okay, each tentacle should be numbered by the respective primitive number. Okay, and create a checkpoint here. Create a null. Checkpoint should be the name ref tentacles. And organize this network here. Now you can test the simulation using a Vellum. But first, let's reduce the amount of the tentacles. We don't need for the initial test too many tentacles. We can reduce a lot this, like 20. We can apply 20 points and create a setup for Vellum simulation. Let's create a subdivide. Just to make the subdivision for each tentacle. Create a color. We can disable here this node just for visualization. We need the gradient in UV attributes later. Just disable this node here. Attribute delete. This is just for visualization. Visualize without the color. Okay, create a color node just to see if the group root is working. Change the red and change it here to group root. Yes, just the root is red because we need to make this point in the Vellum simulation static. Other points except the red should be animated by the simulation. Create a remesh node. In Vellum, it's much better to have triangles instead of this high density quad geometry. Change the type to adaptive. Minimum size should be around 0.01. Yes, we keep a good amount of triangles throughout the whole geometry. We can delete any attributes. You don't need UVs, you don't need color, you just need the name. The name attribute for each tentacle, because we use the name here before the Vellum simulation, because we are going to deformate these original tentacles using this simulation version of these tentacles, these triangle versions. We need to keep these attributes here before doing the cache. Delete everything except the name. Let's create a cache here, just for the frame. Name this to cache, tentacles, remesh. We don't need animation, just a frame. Save the cache. Now you can set up the Vellum simulation. We need to create a Vellum. Vellum strut soft bar for the simulation. Let's connect here. Create a Vellum solver. Connect here the 3 inputs. And before creating the simulation, let's create some nodes here to delete some attributes we don't need after the caching, before the caching, sorry. We need just to keep the name. Delete all the groups. We don't need any groups after simulation. And create a file cache. Cache anemone via Vellum 01. Let's change some parameters here in the Vellum struts. Actually, in the Vellum cloth, we need to fix the points that are going not to receive the simulation. Here in pinpoints, change to group root, match animation, and that's it. In the Vellum struts, let's keep the same default values. In the Vellum simulation, we should decrease the gravity because underwater, the gravity is much slower than the real world, around 0.1. We don't need the tentacles to falling down so fast. First off, doing the cache, change the simulation time frame, FPS 30, start frame around 1, and end frame 200. Okay. Let's create this cache and see the results. The simulation looks weird. Let's fix what happened with the weird simulation here. Oh, sorry. We need to decrease the gravity, make negative. Negative 0.1. Okay. And save the cache again. This is the result of the simulation. We don't have the noise animation yet. We are going to create it right now. But the gravity is working. For the noise animation, we just go inside the Vellum solver and create a pop force. Connect here the pop force to the force output and change some values here. Amplitude should be 1. Surreal size should be 0.3. And the pulse length should be around 10. Let's see the result for these tentacles. This is the result of this animation, which is working, the noise is working. But let's see with the 200 tentacles right now. I will create a cache. First, you need to change here in the scatter tentacles. Let's rename this to make easier to find later. Scatter tentacles points, tentacles, and change here to 200. Here, just recache the remesh and save the cache again, without changing any parameters in the Vellum simulation. The Vellum simulation is working, but right now you need to deform the original geometry with the simulation to make it a cool shader in the render. We are going to use a redshift for the render and shaders. These tentacles is triangulated. We don't need the geometry. We need to transfer this deformation to the original geometry, which is that geometry here. Let's do that right now. Create a subdivide here, ramificating the network. Just create a one subdivide. Create a rest node, rest position. And we need to promote the name attributes from the primitive to the point. And create a point deformer. Connect the original geometry to the first input. Connect the animated geometry to the last input and create a time shift here just to freeze the first frame and delete the animation here. Left click, delete channels, and connect the freeze frame to the middle input. In the point deformer, we need to change the attribute name to name. And actually, we need to promote the attribute here too. Let's change the correct order here. Promote, attribute promote. After the cache simulation, promote the name from primitive to point. Connect this here and connect this to the shift frame. Freeze frame here. Let's see it's working. This is the original geometry. It's working pretty nice. You can actually see the simulation without the UVs and color. Just delete every attribute. And you can see with the texture too. Create a UV quick shade. Oops, before the deleted of the attributes. Change it, select the texture. And you can see here the anemone with texture. Let's delete just the color here. Let's create a flipbook just to see the behavior. That's the result of simulation, this chapter. Before render that geometry in Redshift, we need to create some setup configuration here and make some final cache. Here we need to delete everything except CD and UVs. Let's delete all the groups too. We don't need any groups in the rendering. Let's create a name attributes for the geometry to organize the Solaris network. Name this to Tentacles. Let's compute velocity for motion blur. Create a trail node. Compute velocity. Create a cache node. Rename this to cache. Anemone Tentacles. Final. And create a checkpoint here. Name this to out anemone and change this color to black. Here in the result of the simulation, you can see it's too fast. You can slow down this, change the pulse animation in the pop force inside the Vellum solver, or you just can create a retiming outside here before the cache. Let's create a retime, just to slow down a little bit the tentacles animation. Change it here to speed 0.8. Delete channels here. 1 to 200. Input frame range 1 to 200. Just avoid to interpolate the UVs. Here in the attribute, just interpolate the position. If you are not doing that, you are going to break the UVs for geometry. Let's see what's happening. Here we are breaking the UVs for each frame. We don't need that. We just need to interpolate the position of the points. And you create a slower animation here, just slowing down the speed. And create a cache. That's it for this chapter. Let's create right now, in the next chapter, the body of the anemone. For this chapter, we are going to create right now this trunk, the base of the anemone creature, and prepare this geometry for the shader. Let's go. Now let's create a body of anemone. We need to copy this node here, the tentacle geometry. Goes to geometry node body. Create an object merge. Select the alt anemone. We need to create a group here. Just select the root from each tentacles. Let's go back to the anemone. Go up there here. And create a group here after the transform. Group. Will be called end body. Group name should be $OS. Primitives. Disable base group and enable boundaries ratio. Scale the size of the bounding box. Like this. That's okay. You need to recreate the cache to write this group. The cache is done. Now we can go back to the anemone body. Create a blast node after the object merge. Let's rename these nodes. Keep ends. And delete the end group. Oh, sorry. The group, I think the group was deleted. We need to keep this group here. Let's see. Yes, we need to keep this group. Just to disable this node here and make the cache again. The cache is done. Let's go back to body. Now you can select the group here, okay? And keep only the tips, the root. Let's delete all the attributes. We don't need the color and the UVs. Let's subdivide this by 1 and create a poly extrude. The size of the poly extrude should be around 0.015 and enable the output back here. Create a merge node and we need to copy the same torus from the anemone tentacles. The same node tutorials, we can copy this here. Let's copy tutorials and fuse. Go back to body, paste here, and create a poly extrude as well. Oops. Extrude. Just give a little thickness. Like this. Outwards, okay. And enable the output back again. Connect to the merge node. And you can convert this to VDBs. VDBs from polygons. Change this value here to 005, 005. Create a VDB smooth SDF just to smooth the sharp corners here. We don't need to change any value in the node. Create a VDB resample to change the resolution of our VDB. Change here to using voxel scale only by 0.5. Okay, that's the first step. Let's organize this node here. And you need to fill this area here with another procedural geometry. Let's create a line with the direction 0, 0 in Z. Keep the length of 1. Just create a carve node to trim the line a little bit. Enable the first and second. And the first should be around 0.028. And the second should be around 930. 93, sorry. Let's resample this. Resample by maximum segments 11. Yes, we have 11 points here. And create a bend. A bend deformer. The bend should be in 50. Okay. Copy and transform to make a polar array here, like a circle. In the copy, the numbers should be around 200. And you can put a little expression here. Just left click, copy parameters. In the rotation Y, left click, paste relative reference. Put a 350, divide by this expression. Should be this result. Create now a group range, because we need to create like for each of these lines should be one up, one other down, up, down, like a zigzag. Actually, you can create already a skin just to connect the lines in a unified geometry surface. And you can enable the VWrap here. Create a group range before the skin to select the half amount of these lines. Let's call it a group half. And here, change the select 1 by 2, 1 of 2. And the selection, alternate selection, should be work. Now let's create a transform. Rename this to lift half. In the group here, group type should be primitive. And select the group half in the group here. Lift line a little bit like 0.1. And enable the skin again. It's like a zigzag geometry. Create a subdivide with depth 2. Create a reverse node just to reverse the normals here, because down there is okay in the geometry, but up there is blue. Or you can disable here, this node here, this button. Change back face polygons, but I prefer to reverse the geometry. Create attribute noise, just to break up the correct lines, just to break up the alignment. In the attribute noise, you can change here in the attribute name the position, P. Here the range values change to 0 centered. Amplitude should be 0, 1. And element size 0.4. In the fractal here, reduce the fractals by max octaves by 1. We don't need too much noise here. Now you can create a little vex node just to orientate the normals by in the up axis, the y-axis. Vex and a single line script here, just be at n equals set 0, 1, 0. Like this. To create the normals pointed to up direction. And you can create now a polyextrude. And select the direction of n here. Point normal, existing, actually attribute, and direction should be a negative value. Downwards. And enable output back here. Create a reverse node again to reverse the normals because the back faces are showing. Reverse this. Create a normal node to calculate the normals again. Okay. Create a merge node here because we're going to create a sphere in the middle. In the reference, let's check the reference here. In the reference here, you can see the middle of the anemone body has these alternate skin lines we're creating right now, and just a little sphere, like a little noisy sphere in the middle. Let's create this sphere. Sphere polygon. Merge with this middle zigzag. Adjust the scale. You can clip this geometry here in the Y direction. 0, Y. Let's clip. Yeah, it's working. And you can polyfill the bottom of the sphere. Polyfill, just to close up the hole. Because we need to convert this to a VDB and make a Boolean union with this crown here. Let's move this down here. Let's organize this node here. Okay. Let's check the position of this middle part in regards to the other part here. Let's scale, transform. scale this a little bit and move it down just to, yes. I think scale should be around this. Here in the attribute noise, let's zero out the y-axis. We don't need a noise in the y, just zero out here. You can go to attribute noise, click this button here, pre-component model, and zero out the y. Okay, let's adjust the scale just to fit the hole. I think it's okay. Yes, it's good enough. We don't need to be perfect here because the tentacles should be hiding all this artifact information here. Let's convert it to VDB, this top part. VDB from polygons. This should be 0025. Let's move the VDB. VDB is move SDF. You can see the faceted part of the sphere. You can just increase the resolution of the sphere to avoid this faceted look. Okay. Let's create a simple checkpoint here for each one of this geometry. Here, the checkpoint name will be ref base crown. The checkpoint here, ref middle crown. Let's combine these two VDBs. Create a VDB combine. Connect the base crown in the first node, the first input, and the middle crown in the second input. Activate the node, and here in the here in the operation should be SDF union. Now you can convert this to back to geometry. Convert VDB to polygons. Okay. Another step we're going to do here, before going to rendering, we need to create a mask from these areas here. These contact areas should be create a mask for using the shader in the Redshift. Let's create this right now. For this, super simple. Create a pick node, connect from this node here, polyextrude. Connect here from this attribute node here. We just need the original, trimming the tentacles. Move this node down there. The pick should be pretty small, like 0.01. Let's subdivide this node. High depth around 3. 3 is too much, around 2. Create a color node, and you need to transfer this color information to this geometry here. The first color should be white, and the crowd color should be black to create this mask. Create attribute transfer, connecting the first input, this black color here from the crown, and the second input should be this white color from the tip of the tentacles, the end of the tentacles. We just need to transfer the CD information, CD attribute. CD, in the primitives, disable this, and reduce the distance threshold. A small value, pretty small value, like 0.01. Too much, 0.05. Yes. But we need to blur these edges here from the color blending using an attribute blur. Attribute blur, change this here to color, attribute CD, connect to this, and you can see the change of the mask. But we need more iterations, like 10. That's it. And create a name for all this geometry here. Name, base, brow, and create another checkpoint here. Name this for ref, brown. That's the first step. The second step, we need to create like a trunk, like a tube down there, like a base. The trunk of the trunk from the body of the tentacle's body. Create a tube. These values here should be radius 0.52. Secondary radius should be 0.69. The height should be 1.63. Rows 25 and columns 50. Let's transform this tube and create a merge. Connect the crown here, connect the tube here, create a checkpoint here for the tube, the trunk, ref trunk. Let's move this to the left, to the right side. Let's move this to the right side. Make some space here. We need to create another operations here. We need to adjust the position. Let's visualize the merge and transform the tube. Like this. Okay. Let's create a UV texture in the tube. Adjust the texture type to cylindrical and fix the ends, the seams of the UVs. Enable this parameter here, fix boundary seams, just to fix the connection here, because they are stretching the UVs. Let's create a group. We need to expand like a little bit the down, like a little extrude here, but we don't need to extrude. Just create a scale the bottom of the trunk. Rename this to bottom, group bottom. Here the attribute name change to $OS. Disable base group. And enable keeping boundaries regions. And move the group down there, like yes, okay. Let's transform a little bit this bottom part. Scale by 1.15. Change the Y position. Okay. Create a gradient node, gradient, labs color gradient in the Y. The gradient, the ramp should be in y-axis and invert here. Because we need to create a noise operation here, but in the top part, we don't need to deform too much. In bottom part, we can deform a little bit more. Create a vex attribute here, pointer angle. Rename this to vex mask. Vex mask. In the mask vex, just a simple script like @mask equals @cd.r. Just to create these mask attributes in regards of luminance of these points, luminance from the color. You can create an extrude, a body extrude, change a little bit from to inside and output back here. Make more thick, create a reverse. Create attribute noise. Change the attribute names to P for position. Change the range values for 0 centered. Amplitude should be a little bit lower, 0.15, 16. Reduce the fractals here. Max octaves like 1.2. Here in the blend, enable the blend and change the use attribute. You are going to use the mask in the color to apply the noise by amplitude color. More noise in this region, 0 noise in the top part. Let's delete some attribute. Attribute delete. Just delete the color. We don't need the color anymore. Let's create a smooth. To smooth the edges. And create a name for this geometry. The name should be trunk. This name here is important because we're going to select this geometry by name and apply the shaders in the Solaris. Okay, let's see the final result. Just create a checkpoint here. Alt, base, crown. Change the color to black. The position here is boring. You can move it up there, this, and create like a rotation diagonal. Let's do that right now. Before the checkpoint, create a transform. Move this to up. And rotate a little bit here, diagonal position. Copy this transform rotation, Ctrl C, and paste it to the tentacles, the same values. Just for cool camera position in the shader. Let's copy this. Go back to anemone tentacles and the final network here. You can paste the transform. And the anemones should be in the same position. Let's see both the geometries visible. I think that there's two geometry. Let's organize what's happening here. Let's check. Okay, we applied the double transformation. We don't need to create this double transformation. To avoid that, let's go back to anemone. We need to put this transform here, down there, After this node, create another checkpoint here to avoid conflict. Let's connect this here. This out ref anemone to body. You can use the transform here and use this node here to create the body from scratch. Let's go back to anemone body. Here you can change it to this node anemone body. Let's find that. F anemone to body. Now it's okay. Let's go down there, the hierarchy. It's working. Let's create a file cache here. Just to avoid the processing of the entire network again. Rename to cache body. Disable time dependent cache and cache just a single frame. And you can see both the geometry are working right now. The position is okay. Let's create a flipbook for this, just to see the behavior with the trunk. I want to see with the shader, the texturing. Create a quick shade and select the texture here. That's the final result of this chapter. The anemones with the trunk. Let's go to the shader right now. Shading look dev. Let's go to the shader, to the rendering. We're going to render this in Redshift. Let's go inside this log network, create a SOP import. Name this to base crown. Create another SOP import. Name this to anemone. Let's merge. Let's organize a pretty quick setup here in the Solaris before working the shaders. Here, let's create a render product, render geometry settings, and enable the displacement in the base ground. Let's pick up the geometry here. Anemone body, out base ground. Change the sublayer style to cop SOP. Load the anemone. Anemone tentacles, out anemone. And change the sublayer style to cop SOP. Okay. Create a mesh edit. To add subdivision geometry in the render time. Enable here subdivision and triangle subdivision. Here, just move these tentacles to the path here, primitives, and geometry sets for the displacement. Enable here the redshift, tessellation, enable tessellation, and enable displacement. Put the base ground here in the path. Base ground slash T. Create another render settings geometry to activate motion blurring the tentacles. Put the path here, anemone tentacles in the primitives in the redshift. Enable velocity blur. create a little camera here just to make a cool preview of the animation. Let's see through the camera. It's okay. Let's create a simple animation here in the camera. Move the camera here to path of the primitive of the camera, transform, and create a little animation here. Left click, keyframes, that keyframe in the translation and the rotation. Go down to the timeline and move with the camera a little bit. Here's the animation from the camera, it's okay. Create a material library. Create a material assign. And create some lights here. Let's create first a dome light. And create some area lights here. This area light should be the main specular. Another area light here. Main all. That area light here should be controlled just the specular of the rendering. And that area light here should be the main light, and create another area light and rename this to area light ring. Create a redshift node, rename the redshift to RS, Anemone, building, and set some parameters in the redshift node. First, change the resolution for Full HD, ADTV, plane monitor active. In the mode, click in advanced and increase the threshold for the sampling just for a quick render. Let's organize this network and go inside the material library and create some shaders. The first shader we need to create here for the tentacles. Another shader for base crown. And another shader here for the trunk. Let's apply the shader. Let's create some color identification here. For the tentacles, should be red. Just to identify if the shader was applied correctly for it geometry. Base crown should be green. And trunk should be bluish. Let's output materials in the material library. And in assign material, let's create 3 materials here. And put the geometry. Anemones tentacle. And select the materials. RS tentacle. Base crown. And the shader base crown. trunk, and the shader should be the RS trunk. Okay. Let's preview the render to see if the geometry is applied correctly to the shaders. The shaders was applied. Now we need to tweak the shaders and apply the texture here. Let's adjust the light first. In the dome light, should be small intensity like 0.6, and the text should be a AGR file. In the redshift tab of the dome light, the contribution of the camera should be disabled. Zero out on the camera contribution. All the other arrow lights should be disabled, the contribution from the camera too. In the redshift tab. Let's adjust the position of the arrow lights. For the main specular, like this position here. For the main light, should be the same position. The ring light should be the back side of the tentacles, like this. Okay. Let's go inside the shader and adjust the shader for the tentacles, the base claw, and the trunk. The tentacles, let's create a shader. Let's create a texture. Rename to diffuse. And load our texture here. And apply this to diffuse. In the shaders, increase the roughness. Let's see the rendering. Let's increase the transmission like 0.11 and load the map of transmission here. Transmission. Load the transmission file. The transmission file should look like this. Let's load from the disk. The transmission file is just a mask. Create a full transmission here and no transmission in that position here. But first we need to create some modification in the texture because the texture is like inverted. We need to invert the color white here and black here. Let's create a color splitter for the transmission. We just use the R, create a math sub, subtract from 1, just to invert the mask. Multiply by some value here around 0.8. And add a little bit of information for this transmission, like point 1. Connected the transmission here in the refraction weight. Refraction color should be the diffuse color. Let's see more closer. To see if the refraction transmission is working. Let's increase the transmission here. Adjust transmission is okay. Let's increase the roughness. I think the roughness is okay. Let's increase a little bit in transmission. It's working nicely. Pretty cool. Let's adjust the shader for the crown and the trunk right now. The trunk is a simple displacement shader. Let's create this. Create a maximum noise. This is a pretty cool node for creating noise. Change this here to displacement turbulence. Reduce the octaves to 1. In the input here, change to UVs. Reduce the scale to 0.5 in both X and Z axis. In the Y axis, increase to 30. Create a displacement node. Connect the out color from the maximum noise here in the texture map. And apply the out to displacement. Let's move this up there. Decrease the scale of displacement like 0.02. Let's change some colors here. Let's create another maximum noise. Create another displacement turbulence. In the input, change it to attribute. Overall scale should be 10. Let's visualize this in color. Let's disable the displacement. We don't need displacement right now. Just let's see the colors. Activate the redshift render. For fast preview renders, you can disable the tentacles. You can disable the tentacles here. Just to see the crown and trunk. And later can enable again to the final render. Let's see the look. The color is is working like a fractal. Create a ramp here. Change the color from the ramp here like orange, and here like red, dark red. Okay. Enable the displacement, connect displacement here to see the look. The displacement working nicely, like extract the noise. Like in the reference here, you can see the extract the noise for the body of the tentacle. Let's work in the base crown right now. Let's adjust the full parameters here, like reflection and refraction. Here in reflection, increase a little bit, like 0.3. Increase the transmission like 0.1. You can increase a little bit in subsurface, but I think 0.1 subsurface is enough. 0.1. Create a maximum noise. Change the maximum noise to displacement turbulence. In the output, change a little bit the contrast. 0.7. Let's connect this to the base color and see what has happened. There's a little bit noise here. Let's adjust with the ramp. Some ramp colors. Here again, we can change this to orange. Here with the dark red. We need to import our mask for this crown to apply different colors here in the circle areas, the big circle areas here. Let's do that. For this, we create an attribute, rs point attribute. Change this here to display color. Display color. Create a mix, vector mix. We need to mix this color from this noise. Create another constant color, like a purple. Connecting second input. And the mix amount should be the color, should be the mask we created before. Let's see if it's working. It's working. We have our pick different colors for each tube. That's working nice. Let's see the complete render right now and adjust the highlights, the intensity, because I think it's too flat, they look dead right now. Go to camera, enable the tentacles, adjust it. Let's work in each area light. Let's disable all the area lights and see just the dome light to see if the intensity is good. The intensity of the dome light is good. Disable that. Let's enable the main specular. In the basic properties, disable diffuse multiplier. Increase the exposure to 11. I think it's too much. Let's decrease the roughness from the tentacles in the shader. I think it's too specular right now. Like 0. We don't need the spectrum. We don't need your glossiness. Just disable the weight of the glossiness of the shader. Let's reduce the size of the lights. Decrease the exposure a little bit. Like 5. Okay. Disable the R light and enable the main R light. Increase the R lights to 3 in the exposure. Add some color temperature here, like a cold color. Like a cold color here. Okay. Let's see the ring light, the look of the ring light. Increase the exposure to 4. Yes, I think it's working. Let's enable all the lights and see the look. Let's increase a little bit the main R light. To exposure, let's change it to 4. That's it, guys. That's the final look of the anemone. You can render this animation. And that's it. Thank you, guys. See you next video.